So I wanted to practice some of the applications of the sum and difference formulas. So let's take a look at some problems involving those. And share access to formulas just as you would. You don't have to memorize these sum and difference formulas. You'd be given the sum or the difference, and then everything else should be derivable from that. So for instance, you should be able to derive the difference formula from the sum formula if you need it. Okay, so sine, that's going to be sine, cosine. Plus cosine sine. So really I need to visualize this as a sum. I can use a difference, but I'm thinking of 3/12 and 4/12. So your fraction knowledge comes into scrutiny because it's hard to kind of imagine breaking that apart if you're not feeling good about fractions. This, of course, is pi-fourths, and this is pi-thirds. So this is going to be my alpha. This is going to be my beta. So here we go. Sine alpha, sine of pi-fourths, cosine of pi-thirds, plus cosine of pi-fourths, and sine of pi-thirds. Notice that it really doesn't matter because if I switch the order of these, I would still end up with the same expression. So let's take a look. We got, now here's where my unit circle is going to come in handy. So I need to be able to do both the pi-fourths value and the pi-thirds value, which is up here, right? So this is my pi-thirds value. This is my pi-fourths value. This one we're talking about √2/2, √2/2. And this one we're talking about the x value is shorter, 1/2 square root of 3/2. Okay, so this should help me then fill everything out. Sine pi-fourths, that's the square root of 2/2. Cosine of pi-thirds, cosine is the x value, that's 1/2, plus cosine of pi-fourths, that's square root of 2/2, times sine of pi-thirds, that's the y value for the pi-thirds position. So now we're at square root of 2/4 plus the square root of 6/4. I have a common denominator. I'm going to put them together into the same fraction, but there's not really more I can do. I can evaluate my answer to see that it's right. It's nice to know that I'm right without having an expert tell me that I'm right. So square root of 2 plus the square root of 6, I got 3.86, but I'm not writing that down. I'm just doing it. So my answer for my calculator without rounding is 0.9659. Now I want to see, I got to make sure I'm in the right mode, go to radian mode. What is the sine of 7 pi divided by 12? 0.9659, boop. Feeling good about that. Okay. So you can see there's layers here. Breaking it apart, that's called, needs fraction skills. Then I'm using the formula. I didn't have to memorize it. I just got it from a formula sheet. Then I'm using the unit circle and I'm substituting sine pi-fourths, cosine pi-thirds. I need to know how that works. I need to be able to substitute those. Then I have fraction skills again, radical skills, square root of 2 times the square root of 3. Simplifying, using the calculator as a way to check my thinking. Okay, let's take a look at another one. Tan 75 degrees. Okay, so look at my tan formula, and I'm going to break this into 30 degrees and 45 degrees. So this is going to be my alpha, my beta. I'm going to write down over here. I think in terms of doing these types of problems, it's good to transfer the formula as it's written onto your paper. Then you can go back and forth between what you wrote and what it says and just make sure that it's right. If you start immediately substituting the numbers, you don't have that extra step of being able to kind of go back and forth to check to make sure you've written it out. Okay, so tan 30 plus tan 45 over 1 minus tan 30 tan 45. Okay, again, back to the unit circle. Here's my 30 degrees mark, which is the square root of 3 over 2, comma 1/2. And then I got my 45-degree mark, which is square root of 2 over 2, square root of 2 over 2. All right, here we go. Now these are harder because I gotta do the ratio of sine to cosine. Tan 30 equals sine 30 over cosine 30. So in other words, it's a half divided by the square root of 3 over 2. That's 1 over the square root of 3. I skipped over the fraction division there. It's 1/2 divided by the square root of 3 over 2. That's 1/2 times 2 over the square root of 3. There's simplification there. And I end up with 1 over the square root of 3. So this is my tan 30 value. I'm going to go ahead and pop it in. I haven't worked that out yet. Next up, tan 45. Oh, tan 45 is nice because it's just the same value. So that's 1. 1, 1. Okay, so it's 1 over the square root of 3 plus 1, 1 minus 1 over the square root of 3. Now you might be tempted to stop there because you're like, woo, I already did all the hard work. But actually, the hard work has just begun. Because now we need to simplify this. And if we don't, it just means we're scared of simplifying or we're being lazy. Let's not be scared or lazy. Common denominator, square root of 3 over 3. Common denominator, square root of 3 over 3. Sorry, square root of 3 over the square root of 3. So I end up with 1 plus the square root of 3 over the square root of 3 divided by the square root of 3 minus 1 over the square root of 3. Now I'm going to write it sideways. Anytime I have a fraction and a fraction, I'm going to clean it up, try to get it simplified down to one fraction. Square root of 3 minus 1 over the square root of 3. Keep change flip. I am going to get some simplification with that square root of 3 here and here. So I end up with 1 plus the square root of 3 over square root of 3 minus 1. And for a bonus, I'm going to rationalize this because these are so similar. I just feel like it's going to clean up a bit. How do I rationalize this? Get the square root of 3 out of the bottom. I need to multiply by the conjugate, square root of 3 plus 1. Top and bottom, I can multiply the top and the bottom by anything I want, as long as it's the same. Difference of squares, square root of 3 times square root of 3 is 3. I'm focused on the bottom first, sorry. This really should be in parentheses too. Minus 1. So the denominator is going to end up as 2. Now let's think about foiling out this top. Square root of 3, 1, 3, square root of 3. Square root of 3 plus 1 plus 3 plus the square root of 3. So in other words, 4 plus 2 square roots of 3 all over 2. Ooh, this is beautiful. 2 plus the square root of 3. I'm distributing the division there. 4 divided by 2, 2 square roots of 3 divided by 2, simplifying it out. This cleans up a lot. 2 plus the square root of 3 is the answer. What was the question? Oh, tan 75. Let's check. Check my mode. I need to go to degrees. I want to do tangent 75, 3.732, maybe about a bit. And then 2 plus the square root of 3. I got a good feeling. Dun, 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 dun. Boy, that is some heavy duty simplification. All right, last one, cosine 15. Let's do a little bit of subtraction. So this could be cosine of 45 minus 30. So again, I'm going to go out and get the cosine difference formula. Now, let's say that I've not been provided with the cosine difference formula. Let's say I've been provided with the cosine sum formula. Well, two ways I can think about it. I can derive the cosine difference formula, which I've already done for you, or I can just think about this being 45 plus negative 30. Right? So if I think about it this way, I can use the sum formula. Alpha is going to be 45, beta is going to be negative 30. Let's see what happens. Cosine alpha, cosine beta, minus sine alpha, sine beta. There we go. Cosine 45, root 2 over 2, cosine negative 30. Now, I could use the even odd principles here, but I can also just evaluate what it is, right? Cosine negative 30 is down here, negative 30 degrees. That's square root of 3 over 2. Minus sine of 45, square root of 2 over 2. Sine negative 30. That takes me to negative 1/2. And so then we end up with the square root of 6 over 4 minus the square root of 2 over 4. Oh, almost made that sign error. Negative times a negative. Square root of 2 plus, sorry, square root of 6 plus the square root of 2 over 4 is my final answer. When I'm doing that, anytime there's multiple negatives involved, my mind is always circling back and saying to get the signs right, to think about it right. But that first thing that came out of my mouth was just minus, and then I was doing the multiplication and not really thinking about the, so I had to go back and think negative times the negative is positive. Okay, cool. That's it. There's some examples of using this sum and difference formula for sine and cosine and even tangent. Fun on a Sunday.